Hello, this is our final project presentation.
And for our project, basically what we did is developed a portfolio model, which analyzed six key assets, those being Costco, Meta, United Health Group, a gold index, Tesla, and Bitcoin. And basically we use Excel solver to find optimal asset weights for each of them. And we were trying to address the problem of finding capital allocation efficiency.
We decided to choose this topic because a few of us took a portfolio management class, and so we were all interested in the portfolio optimization tool that we built in class. And we thought that this would be a good opportunity to apply our prior knowledge with the new skills that we learned with Excel and financial modeling from this course.
Some of our goals with this project were to build a functional portfolio optimization model and to have it be dynamic with an interactive dashboard.
The first method we used was using Solver to find optimal portfolio weights, and then we use index match functions to create a dynamic set of graphs and an interactive dashboard.
This takes us to where we actually ended up with our workbook, and we're going to share our workbook now.
Yes, so for the first part of the back end of our models, here on the left-hand side, you can see monthly returns for Meta, Costco, United Health, Tesla, our gold index, Bitcoin, and the S&P 500, which was our index. This was grabbed from Wharton's CRISPR database, except for the returns for Bitcoin. I think those were adjusted closing returns from Yahoo Finance instead. So then on the right-hand side, we have the expected returns of each of our assets, and as well as the standard deviations. And then in the bottom right-hand corner, we got a covariance matrix, which we use in the second half of the back end of our model.
Then we took these expected return standard deviation tables and covariance matrix tables to help us solve for the optimal portfolios that lied on the minimum variance portfolio, which would be the portfolios that maximize expected return and minimize risk. So for each portfolio, we have a expected return, and then we just added 0.002 to each one, and we created 11 different portfolios, minimizing our objective when solving using solver was to minimize the variance by and then also adding constraints that each portfolio would equal one and that the expected return would equal or the target return would equal to the expected return. And then this was the graph that we ended up with on our minimum variance portfolio. And then we solved for the optimal risky portfolio, and we maximized the Sharpe ratio in this instance, and this was the portfolio that we got, subject to the constraint that all weights equal one. And then we also used this method, the optimal risky portfolio method, to solve for the marginal benefit analysis that we created. So each portfolio is excluding one asset, and that is the one additional constraint that we added, and that's the only difference that we have between the optimal risky and the portfolio. And then one other thing to add is our dynamic title on the dashboard is here, and then we also created some labels right here that would help us with index match in our dashboard.
So onto the dashboard, starting at the top left-hand side, color-coded in green, that's where the user would select the month of their choosing. Their selection will then provide returns for each asset on that date using the index match function. And it will also provide returns for each asset using optimal risky portfolio weights. And then on the top right-hand side, again in green, we used conditional formatting to determine portfolio returns and the S&P 500 returns. which makes them either green or red depending on performance.
Moving on to the blue section on the bottom left side, uh, there is a drop-down menu which lets you choose a target return ranging from 0.5% to 3.4%. To the right of that, it'll tell you the variance, standard deviation, and Sharpe ratio of the portfolio depending on the return selected. Below that, it'll show you the optimal weights. And then there's a dynamic graph which shows any negative weights in red and positive weights in green for each asset. Moving on to the orange and the pink section. The orange section is just the optimal risky portfolio. It shows the expected return, the standard deviation, and the Sharpe ratio. And then in the pink section on the left-hand side, you can choose to exclude one of the assets through a drop-down menu. And then it'll show the expected return, standard deviation, and Sharpe ratio as well for each of those assets for that portfolio. And then the graph is a dynamic title, and it'll say excluding whichever asset you chose, and compares the expected return, standard deviation, and Sharpe ratio of the portfolio with the excluded asset and the optimal risky portfolio.
So reflecting on how we did, our biggest success was being able to actually build a functional interactive dashboard, which is something that we were excited to build, but we're also a little intimidated by the challenge. And uh, another success that we had was adding the marginal benefit portfolio analysis because this was a great idea and it helped us gather interesting data that we could add into our dashboard. And some of the obstacles that we had was finding returns for Bitcoin and narrowing down the actual things that we could build into the dashboard. Thank you.